All right, let's demystify the world of programming. We're going to take a simple idea and translate it into a language a computer can actually understand. And hey, by the end of this, you'll have written your very first lines of C++ code.
Now really, think about that for a second. Have you ever just wished you could give a computer a perfect set of instructions and have it follow them every single time without getting it wrong?
Well, that's exactly what programming is. It's all about giving those precise instructions. And the language we're going to use is one of the most powerful out there, C++. This is the beast that runs high-end video games, complex financial systems, even space missions. So let's start with a classic tradition.
Every single programming journey starts with the same first step. It's this legendary tradition called Hello World. It's basically the simple act of getting your program to say hello. It's like its first word.
Now, before we write a single line, it helps to know where C++ even comes from. Think of it like an evolution. It was built on top of an older language called C, but it added this powerful new idea called object-oriented programming. We'll save a deep dive on that for another day, but just know that C++ stands on the shoulders of a giant.
And here it is, your very first program. Just 5 lines of code. Now, I know it might look like a totally foreign language right now, but trust me, every single symbol here has a purpose. Let's break down exactly what's going on.
Okay, time to put on our detective hats. We're about to investigate the key ingredients of a C++ program to really understand how this whole thing works.
So, to write code, you have to understand its syntax. And honestly, the best way to think about syntax is just, it's grammar for computers. You know what English has rules about where to put periods and commas? Well, programming languages have super strict rules for structure. Get the syntax right, the computer understands you. Get it wrong, you get an error. Simple as that.
Let's look at the ingredients in our Hello World recipe. That first line, #include IOStream, is basically telling the program, hey, go grab the toolkit for handling input and output. Then you've got int main with those curly brackets. That's the main stage. It's where everything kicks off. Cout, which we say like see out, is the program's megaphone. It's how you display stuff on the screen. And that little semicolon at the end, that's the period of C++. Every single instruction has to end with one.
You know, printing Hello World is a fantastic start, but what if we want our program to be, well, more interesting? What if we want it to actually remember things or even interact with us? To do that, we need to give our program a memory.
To remember things, programs use what we call variables. And the absolute simplest way to picture a variable is to think of it as a labeled box. You can stick some information inside the box, and whenever you need it again, you just call it by its label. So, we could have a box labeled user age and just pop the number 25 inside.
Now, you can't just toss anything you want into these boxes. You have to tell the computer what kind of information each box is going to hold. We do that with data types. So an int holds an integer, a whole number. A string is for text. A double is for any number with a decimal point. Char is for just a single character, and a bool, that's short for Boolean, can only ever be one of two things, true or false.
Okay, so we know how to make our program talk to us using cout, but for a real conversation, it has to be able to listen too, right? For that, we use its counterpart, syn, pronounced cin. This is what lets our program take input straight from the user's keyboard.
Getting user input is kind of like a little 4-step dance. First, you ask the user for something with count. Second, you prepare a variable, an empty box, to store their answer. Third, you listen for what they type using syn, and you put that input right into your box. And finally, you respond using count again to show them you got it.
All right, this is where programming starts to feel like a superpower. We're about to go beyond just following a list of instructions. We're going to teach our program how to think for itself, how to actually make decisions.
So how does a program decide? Well, it compares things. It uses these simple operators to ask questions that can only be answered with true or false. Is A less than B? Is A not equal to B? And hey, pay close attention to the equal to. It's a double equal sign. Using a single one by mistake is probably the most common bug for beginners. These simple comparisons are the building blocks of all logic.
So, the most basic way a program makes a choice is with an if-else statement. The logic is exactly how we think. If some condition is true, the program runs one chunk of code. Else, if it's false, it runs a totally different chunk. It's just a simple fork in the road for your program.
But what if you have way more than two choices? A long chain of if-else statements can get pretty clumsy.
A much cleaner way to do it is with a switch statement. You give it a variable, in this case day, and it checks it against a list of possible case values. When it finds a match, like case 4, it runs that code, and then the break command tells it to stop looking. It's like an old-school switchboard operator connecting you straight to the right line.
Woo! We have covered a lot of ground, from just saying hello all the way to making decisions. So let's just step back for a second and see what you can actually build with these new tools. You officially have your first C++ toolkit. Think about it. You can write a program that communicates, that remembers, that listens, and that thinks logically. These are the absolute core skills every single programmer uses. I mean, with just this, you could build a simple calculator or even the beginnings of a text adventure game. The possibilities are already starting to open up.
And that's really the big question, isn't it? We've just handed you the fundamental building blocks, the basic grammar for telling a computer exactly what to do. So take these tools, get creative, and ask yourself, what will you create first?